Good morning. Welcome to a new chapter. What we're looking at today, we're going to kind of start to bounce around a little bit with a couple different types of material. We've gone through a couple chapters where we've seen the same or very similar things for a number of days. Whether it be slight changes or just the fact that we want to spend a few days on something. But today we're going to be looking at functions, deciding if we are looking at a function or something that is not a function. It starts pretty simple. All you're looking at today, all you're looking at today is deciding whether or not the image that you're looking at represents a function or not. So there's a couple different ways that you're going to see this. First of all, you're going to be looking at a couple problems where you've either got this mapping diagram over here. Okay, so we've got a mapping diagram on the left-hand side, call that a map. And then on the right-hand side, you've got this set. Of course, it's going to be glitching on me here. You've got this set of ordered pairs. Now, they're both technically representing similar things. If we look at the left-hand side, this map, your domain is all of your possible x values. And then if we look over here at the set, all your possible x values are in the x position in the ordered pair, right? Your ordered pairs are always sitting as x, y. So we've both got all of our x values listed, and then your range in the map would be all of your possible y values. Or in the set, it's everything in the y spot. So what we're looking at, is it a function or is it not a function? Well, the map is pretty easy. You really are only focusing on the domain for a mapping diagram. If any of these x values have more than one arrow coming out of it, it is not a function. Basically what this is saying is every input, every domain value can only have one output. Okay, now some of you might be noticing, well, what about over here on the range, this y value, this 0 has more than one arrow coming to it. This rule does not apply for the range. It doesn't matter. There can be as many arrows pointing at a single range value as we could come up with. The domain is what counts here. Each input can only have one output. Otherwise, you don't have a function. So when we're looking at this first one, only one arrow here, one arrow here, one arrow here, one arrow here, one arrow here. There's nothing on there that has more than one arrow coming out of the domain, so this would be a function. That first one would be a function. It's a similar situation in these sets. If you want, you could turn your set into a map. Some people do that because a map is more visual. Or what we're looking at is the same thing. Each input can only have one output. So what would that look like here? Well, each of the x's can only be going to one type of y value. So where I've got a -7, if this was a map, right here there'd be an arrow to an e, right? Because my -7 is paired with an e. Then at my 0 and my h, I'd have a 0 with an arrow to my h. Then if you notice right here, what's happening here is a -7 going to an x. So there's a reason that each value is only listed once in the domain. Because this same -7 now that was back here, instead of being paired with e, is now being paired with x. This is what cannot happen. So you found an x value that is going to more than one y value. Since that's happening, this is not a function. So let's look at a couple more real quick. I won't make sure to write down as much of that stuff again. Let's just kind of look at these two a little quicker. So what are we looking at? We're looking at the domain. Are there any domain values that have more than one arrow coming out of them? Yeah. You've got a 4 that's going to both the 3 and the 0. That means this is not a function. Okay? Then we're looking at, over the right side, we've got relation 4 over here. Remember what happened up top for this to not be a function. You had an x value that was paired with two different y values. Well, my 2 and my h, that's all good. Then I've got my 6 and my m, fine. But then it's telling me 6 is with v and 6 is with t. I've got an x value with multiple y values. That is not a function. Okay, each x can only have one specific y. So that's one type of problem you're going to see. These two things are on one screen on your first 3 ALEKS problems. You'll have a couple of these and a couple of these together for each question. Then we go down here, and this is the vertical line test. A lot of us tend to overcomplicate this. It's very simple. Not necessarily easy. I know these things aren't always easy, but it's simple. This is visually nice for us. All you're doing, you're asking yourself, if I draw a vertical line anywhere on this graph, let's just look at graph 4 right now. Anywhere on that graph, it can never hit my graph twice. Anywhere on my graph. So if I'm looking at graph number 4, no, we can't put horizontal lines in. That's not the test. It's a vertical line test. No, you can't put diagonal lines in. It's a vertical line test. Vertical lines. Will any vertical line that I draw hit my graph more than once? Nope. For these parabolas over here, graph number 4, that's not going to happen. What did I just do there? Okay. So I know it may look like we could draw a vertical line somewhere like right here that's going to hit the parabola twice. It's not. Parabolas going up or down are going to be functions. You're never going to hit that graph twice. So when we're looking down at, or over at problem number 6 here, again, vertical line. Can I draw a vertical line that's going to hit my graph more than twice, or more than once, excuse me. Actually, yeah, almost every vertical line I'm going to draw here is going to hit the graph twice. Oh, sorry, we didn't even talk about what the answer would be. So if my graph passes the vertical line test, so there are no vertical lines that could hit my graph twice. Nowhere on here is any vertical line hitting my graph twice. That means it is a function. So that's a yes. Number 6, there's all these spots where my graph is getting hit twice vertically. So that's a no. And it only has to happen once. If there's even just one spot on your graph that doesn't pass this test, it's not a function. Okay, a couple more, then we are done here. So we can kind of pick it up here through these next couple problems. Oh, Wilson's excited about the vertical line. So again, any vertical line here going to hit my graph more than once? Yeah, actually pretty much everywhere on the graph. So that's going to be a no. That is not a function. These ones are tricky when we're looking at graph number 2. The first thing we need to remember is the open circle versus the closed circle, like we did on graphs, or on number lines when we were graphing inequalities. This means that it is included. This open circle means that that point is not included. It means your line goes right up to it, but it doesn't count that piece. So when you're looking at a vertical line test, Some of us might think, yeah, right there, if I draw a vertical line, I'm hitting this point and I'm hitting this point. But since this bottom one is not included, that's not a point right there. Okay, that is not a point. What's actually happening is the only point for that vertical spot is right here. So that works out both here and here. And those are the only two places where vertically there would be more than one point. So since we have an included and a not included, this actually works. That is a function. Now, that might feel a little confusing. Again, this is yes. Let's look at, okay, what if one of these was also included as well? So if, oh man, if this one was filled in and included, then if that were the case, you would end up with 2 points on the line vertically there. Then it would be no. So just pay attention to if they're filled in or not filled in, included or not included. Last one, when it's separate points, just make sure that you are paying attention to everything going from left to right. So a lot of you guys think, yeah, this is a function right away. There's no lines that could be hitting it twice. So be careful. Look at every point and just ask yourself if there's any other points on that vertical line. Glitching again. There we go. If there's any other points on that vertical line. Nope, that one's good. This one, nope, that one's good. That one's good. That one's good. And this last one, we see that there are 2 points ending up on that line going up and down. So this would then be a no. We do not have a function. Okay, a lot of specific type of questions here that you're going to see, but most of them are pretty visual. Alex will have some, I think you're going to get 3 of each of these questions. Alex is going to have some examples for you to look at, things to help you out in the assignment. So take a look at those. Let us know if you have any questions, and enjoy the long weekend. You guys get Friday, Monday to have a little bit of an extra break. So we will talk to you guys later. Wilson, have a good weekend.